The following video deals with 6 more trig functions, or 6 more trig solving problems. So let's solve these in the indicated domain. Just a reminder that cotangent is 1 over tangent. So that means I have 3 tangent x equals 1 over tangent x. Then I'm going to multiply the tangent over, so I have 3 tangent x equals 1, or tangent squared x equals 1. Now I'll divide by 3. So tangent squared x equals 1/3, and tangent of x equals plus or minus the square root of 1/3, which is plus or minus root 3 over 3. So if I'm looking at that case, well, I guess first of all, we need to make sure that tangent or x is not a value that makes tangent 0, because then we would have a major domain issue. And so that occurs when y is 0. So as long as my answers are not 0 or pi or 2 pi, then I'm fine, since I have an interval that I have to look at. So tangent is root 3 over 3 when I have this situation, and that occurs in the first or third quadrants. So it's a 30-degree reference angle, or a pi over 6 reference angle. So x equals pi over 6 and 5 or 7 pi over 6. And then it's also true in the negative case, because I have a plus or minus. So x equals 5 pi over 6 and 11 pi over 6. And those are my 4 answers that I have for 0 to 2 pi. In this problem, I have 1 minus 2 sine squared theta plus 2 cosine squared theta equals 0. We can do this in either sines or cosines. I will choose cosines just because. So I'm going to use a Pythagorean identity and replace sine squared with 1 minus cosine squared. So I have 1 minus 2 plus 2 cosine squared plus 2 cosine squared equals 0. So now let's combine terms. I have 4 cosine squared minus 1 equals 0. So cosine squared equals 1/4, which means cosine theta equals plus or minus 1/2 when I take the square root of both sides. Cosine of theta is equal to 1/2 at 60-degree reference angles in the first and the fourth quadrants, and it's equal to negative 1/2 at 60-degree reference angles in the second and the third quadrants. So if I'm looking at this, theta is going to be equal to 60 degrees, 120 degrees, 240 degrees, and 300 degrees. That should be a 0. Sorry, friends. But notice that I have to be between negative 180 and 180. So these two answers, I actually have to subtract 360 from them to get answers that I really want. So I have negative 120 degrees and negative 60 degrees. So I have 4 answers, and those are it, between negative 180 and 180. Number 3, I have a cosine coalition. So cosine of 3x and 12, and remember that it changes the sign. So I have cosine of 3x plus 12 equals 1/2. Notice that my answers are between negative 120 and 120. Cosine is equal to 1/2. Once again, we're in degrees. Cosine is equal to 1/2 at positive 1/2. So that's in the first quadrant and the fourth quadrant. And that is a 60-degree reference angle when that is the case. So 3x plus 12 equals 60 degrees. It's also in the fourth quadrant, so 3x plus 12 equals 300 degrees. It's probably a little bit more effective for me to not use 300 degrees, because if you notice, I'm between negative 120 and 120. So it might be a little bit better to use negative 60 degrees as another option here. So when I solve these, I get x equals 60 minus 12 is 48. 48 divided by 3 is 16. And then I get x equals 60 minus, or negative 60 minus 12 is negative 72, and then divide that, and I get negative 24 degrees. So now I have two answers that I know work. Remember from last time, this 3 changes my period. So normally I would add 360 or subtract 360 or something like that. Well, in this case, what I now have to do is I now have to add 120 or subtract 120. So if I add 120, I get 136. That's already outside my period, or outside of my domain. So I can't add 120 to 16 and get an answer. That's actually inside of what I want. But what if I subtract 120? If I subtract 120, then I get 16 minus 120 is negative 104. That's within negative 120 to 120. So I do have another answer that ends up working out. In addition to 16, I get 16 and negative 104. Now, if I take negative 24 and I subtract 120, I'm going to be outside of my domain. But what if I add 120? So 120 minus 24 gives me 96. So I actually end up with 4 answers here that make this work. X equals 16 degrees, 96 degrees, negative 24 degrees, and negative 104 degrees. So I have to actually look to see if I can add or subtract 120. Remember, it's 120 because of the period change on cosine here, 360 divided by 3. And so I end up with 4 answers that are within the domain that I was requested to get. Number 4, I have tangent of a plus b. So in this case, that's going to be tangent of 10x plus 50, and that equals root 3 over 3. So tangent works at root 3 over 3 in both the first and the third quadrants. And that is going to be in this situation. So I have a 30-degree reference angle. So 10x plus 50 equals 30. So if I subtract 50 and divide by 10, I get x equals negative 2. That's not in my domain, but at least I can manipulate things in order to get what I need. So notice that my period for tangent is normally 180 degrees. I have this 10 in front, so I'm going to divide by 10, and my new period for tangent is now 18 degrees. So what I'm going to do is I'm going to take negative 2, which is not in my domain, but I'm going to add 18 a whole bunch of times. So things that will be in my domain: 16, 34, 52, 70, and 88 degrees. All of these are for sure correct answers between 0 and 90. It should make sense that I would have 5 correct answers between 0 and 90 for a tangent problem, because I typically end up having 2 correct answers in a 360-degree window, or 1 correct answer in a 180-degree window. That's typical for a tangent problem. So it makes sense that it gets multiplied by 5 when I have a period change of 10, because that would mean that I would normally have 10 correct answers in a 360-degree window. But let's just double check and make sure that everything's okay on the other end, because what if I have, like, what if I go in the third quadrant? Because the third quadrant is also correct for a positive value. So 10x plus 50 equals 210. So I subtract 50 and divide by 10. So I get 160 divided by 10. That's 16 degrees. The good news is we already found that, and if I kept adding 18, I would end up getting all of these correct answers. So I could also double check by making sure that the third quadrant one works, but it ended up working out in that problem where I don't need any extra answers. Number 5, this is in real radians, so that means I'm going to add 2 pi n to the end of my answers as long as I don't have some sort of period change. Looks like this is factorable, so 2 sine of x and sine x, and then 1 and 1. So I have sine x equals negative 1/2 and sine x equals negative 1. So sine of x equals negative 1/2 has pi over 6 reference angles, and it's in the third and fourth quadrant. So x equals 7 pi over 6, and x equals 11 pi over 6. And then sine is equal to negative 1 at 3 pi over 2. So I have these three answers. And then I have to add 2 pi n, or subtract, well, n is an integer, so it could be positive or negative. So this is going to end up adding 2 pi as many times as I want, or subtracting 2 pi as many times as I want. And then I end up with 3 different possibilities where I have an infinite number of answers here. Okay, secant is equal to 1 over cosine. So I have 4 cosine theta equals 3 over cosine theta. Just a reminder, where is cosine of theta equal to 0? Cosine of theta is equal to 0 at pi over 2 and 3 pi over 2. So if those end up being, 90 and 270. So if those end up being possible answers, then we have a problem. So now what I'm going to do is multiply the cosine over. So I have 4 cosine squared of theta equals 3. Divide by 4, I get cosine squared theta equals 3/4. And then I take the square root of both sides. So cosine of theta equals plus or minus root 3 over 2. This occurs at a 30-degree reference angle in both the first and the fourth quadrant. So that would be my picture. And since it's a 30-degree reference angle, I'm going to say that cosine of theta, I don't need to say cosine of theta, I'm sorry. So I will say that theta equals 30 degrees, or theta equals 330 degrees. But just a reminder that my answers have to be between 0 and 180. So because that's the case, then, I almost forgot. I had a plus or minus. So that means I need the second and the third quadrants as well. My fault. So I have 30 and 330. And then I also have 150 and 210. The 210 and the 330s don't work in this problem because they're outside the domain. So that means I only have 30 and 150 as my answers. Now, what if I change the problem slightly? What if I have the exact same problem for cosine, but I change this to be something like 2x minus 12? And it's still between 0 and 180, non-inclusive. Well, if I change the problem slightly, I would still end up with the exact same situation. I have cosine of 2x minus 12, or cosine squared of 2x minus 12 equals 3/4. I would end up with cosine 2x plus 12 equals plus or minus root 3 over 2. So I still have these 30-degree reference angles in all quadrants. So I would have 2x plus 12 equals 30, 2x plus 12 equals 330, 2x plus 12 equals 150, and 2x plus 12 equals 210, exactly like I had up here. I'm just replacing all these thetas with 2x plus 12. So if I solve all of these things, I get x equals 9 for the first one. For 2x plus 12 equals 150, I get 138 divided by 2, which means x equals 69. I get 330 minus 12, which is 318, divided by 2, which gives me 159. And I have 210 minus 12, which is 198, divided by 2 gives me 99. So I have x equals 9, 69, 99, and 159. So I end up with 4 answers. Notice that all of those are between 0 and 180. So notice what happened was, in this original problem, I ended up with 2 answers and then 2 that didn't work. But in the modified problem, I ended up with 4 answers and all of them worked. And notice that the period change is going to mean that I add 180 or subtract 180. Well, if I add or subtract 180 to any of these answers, I'm going to get something outside of my domain. One last thing, what if I had 0 to 360 in this problem? I would have to add 180 to all of these answers as well, and I would end up with 8 possible answers. So I have 9, 189, 69, 249, 99, 279, and 159, 339. Those 8 answers would all work if it was 0 to 360. So a lot of different possibilities for answers would come up depending on what the solutions are and what my domain is and whether I have period changes and things like that.